Welcome. New year. More Haskell. Maybe more programming in general. I don't know. But probably more Haskell. We'll see what the new year brings. Maybe it's a time to turn a new leaf. We'll do some assembly next. Yes. But welcome. I'm Agent Ultra. I'm here to hang out and write some code, learn stuff, show some functional programming, that sort of thing. It's 2025. Last year we did all kinds of cool projects. We did a couple of games. We did like Asteroids. We did like more of like a simulation roguelike game called based off a game called Super Trek. Worked on a text adventure engine. What else? And this project that we've been working on for a little while now, called Wave Function Collapse, trying to learn how that algorithm works and how to implement it in Haskell. And yeah, we're kind of here. We kind of have like something of an implementation going, but it's not quite working the way we want. Something either with the way the pixel data is loading or not being loaded properly, potentially, or like there's a bug somewhere in all this code that we wrote, and we have to figure out what's going on there. So that's what we're gonna do. We're gonna try and figure it out. Welcome back to the stream for a new year. Yeah, and if you've got ideas for future projects you might want to see me try out on the stream, you might want to learn about, feel free to, ping me in the chat and stuff. And yeah, we'll get to it. There's one more little setup thing here that I forgot to do before I started the stream, and then we're gonna be good to go here. Okay, boom, boom. All right. So let's jog our memories a little bit of where we were. Okay. Basically, this little bit of data here in this block on line 18 is the output of loading our input texture, the image, the source image that we're going to generate our larger texture from, right, here. And this next line, line 19, this texture here is our output texture, much bigger image. It's supposed to look somewhat similar to our input image. All right. Data. I don't know if I've got a file opener set up for this the way I'm doing it here on the command line, but anyways. Yeah, no applications found for but there we go. It's opening up in CRUD anyway. Anyways, so like our input image is supposed to be like this small, tiny little image. We're supposed to get like a self-similar kind of bigger version of that generated by the algorithm. Unfortunately, what we're getting is more like nothing that looks good. Don't know how to open it, but maybe we can. Oh, right, there it is. Yeah, it's supposed to look like this. I'm getting a lot of data that's not supposed to be there. We're getting an image that looks like this, right? So like these colors don't really exist in this source image. So like probably something going on with the pixel data here. Something dumb happening here that I'm doing with that. And yeah, or potentially with the algorithm itself. So looking at the source, like not the source, the this printed out data structure here, this texture thing, we're basically trying to load the data naively into an array, essentially. Right, so at coordinate 0, 0 in the array, like a two-dimensional array, this just 0 is the value here, right? Which like could be black in the PNG format. Could be. Seems reasonable anyway, if it was. But like at 0, 0 algorithm here on the output texture at 0, 0, decided to put um, 0, 0, decided to put 0 as well. And for some reason, this is like translating to dark blue, I guess, when we go to render this texture. So I'm not exactly sure what's happening there. But we're going to figure it out, hopefully. I want to see this. I want to see this texture. I want to make sure that we're actually, like, you know, doing things right. But I imagine if we picked 0 in the input source image and we like try to render that, then it should be 0 in the out. It should be like black should be black, right? There should only be the colors in here. So let's look at the loading code that's like getting data out, because we're doing some pointer conversions, as I recall, some shenanigans with pixels. Yeah, so we get a pixel, we get a pointer to, from this STL function, surface pixels. From this image surface, we get a pointer. And the idea with this expression here, sequence, is that we're trying to get the pixels out from that pointer. Oh, that's my little Canadianism coming through. I haven't noticed that before. But anyways, dude, getting the pixel pointer out from the array at x. It looks like we determine x to be a value from 0 up to image width times image height minus 1. So we're kind of expecting pixel pointer here to be a flat array. Right, and with indices in this range, pardon me. That could be not right, maybe. Maybe what we're seeing here is junk data. I don't know, like maybe 0 isn't black like we think in this format. Maybe it should be something else. Because the other pattern I'm noticing here is that like these should like the output image should have the number, at least the numbers from the input. I don't know if there are numbers out here that are not in the source image. Like 14, that one's in there, that one's in there. That was a pretty common one, it seems. 6383, 14, like we picked that one a lot. We picked 0 an awful lot. Which could be fine, it's just not, and maybe that's the right thing, it's just we're rendering it. It's getting rendered weird. It's like, so it could be the source data we're picking out is not right, and like the algorithm's actually running fine. Right. It might be a translation thing if the data in the output had like contains values that aren't in the input. That would be weird. And that would suggest that we're like manipulating the pixel data, but I don't think any of the code does manipulate any of the values there. It just reads them and then like reorganizes them like in sort of like generate the outputs. So I'm spotting one, but like I'm not really good at reading a giant screen full of numbers. I'm finding Waldo, but I think that's probably right. The input contains some numbers we don't see in the output. That could happen. But at least the inverse isn't true. So that's probably right. So maybe the problem is like in here we're reading junk data in and we're getting junk out. So I'm going to look up the SDL documentation and get surface pixels. All right, so in this C++ example, this person is also getting a pointer to the surface, extracting the pixels from it. I assume our our Haskell wrapper is kind of doing that under the hood. The SDL2 docs. Surface. Oh, just surface pixels. Surface pixels. Yeah, there we go. Okay, we should be locking and unlocking the surface with bracket, but probably not. Unless we are up here. Probably not. Okay, so like that's probably roughly what it's doing. Raw.surface pixels. There's a storeable instance for surface. That's it though. Oh, sorry. No, that's surface. Where were we? Surface pixels. Oh yeah, surface pixels. Just a record field there off of the. Yeah, here. Just the null pointer on this record. Okay, so they're kind of doing a similar thing. Trying to index into the array. Width times height. Well, plus x into it, I guess. Which I think our get pixel might be doing. LM Variable x. No, we're not, but they're having a problem with this. This is the answer, right? Yeah. Yeah, many images have a pitch greater than their width. Okay, yeah. So we're probably just getting data wrong, maybe. This one's upvoted 10. Yeah, looks. I think we're probably just getting it wrong. And I was kind of I think I was kind of unsure of that too, because of like pixel formats and stuff and the way they go with images. Unless it's a very simple format, it's probably got stuff like this. So like this might not even be. This might work maybe for PNG. But it probably wouldn't work on all. stl get RPG. Okay, and this is a getter for getting RGB files from the pixel in the specified format. Okay. Format details, palette. And then pointers to fill in RGB. Uh, 3.13, not 2. That's useful, though. So we could maybe try something like this. I think PNG is, if I'm not mistaken. $32 bytes. All integers that require more than 1 byte must be in network byte order. Most significant first, then less significant in the second. Pretty typical. 2 byte integers, 4 byte integers. Either grayscale or RGB. Huh? All values range from 0, representing black, to most intense at the maximum value for the sample depth. But the maximum value at a given sample depth is 2 to the power sample depth minus 1, not 2 to the power sample depth. Not necessarily linear. Gamut chunk specifies the main characteristics of the values and viewers from source data with precision not directly exported in PNG. Must be scale plus bit depth. Okay. So there's a bit depth order, there's a number of bits per sample, image data. Okay, grayscale, through color, through samples. Here's first, so red, green, and blue. And then the bit depth specifies the size of each sample, but not the total pixel size. Multi-sample pixels at 8 to 16 bits. Scan lines begin on byte boundaries, all that stuff. And then an alpha can be included, which would be another byte. So this one is getting the bytes per pixel. Okay. Address into the pixel we want to receive. So take into account the pitch as the width. Okay, plus the column into it times the bytes per pixel. Okay, and if we have 1, then we return just that byte there. If there's 2, then it's okay, A16. If it's 3. Okay, so then, yeah, this seems to line up close to what specs says. Case 4, UN32, that would be with the alpha channel. So it might not work for all PNG images, but I think this code would work perhaps for ours. Oh, and then they're using the getRGB function here to pass those in. Okay, let's try and translate this into our getPixel function. So perhaps not a CUint pass that we need to do here. Or, no, well, yeah, CUint. But this part. Bytes per pixel. Service dimension. What's the raw types have? Bytes per pixel, there it is. So we get the pixel format. Surface format. It doesn't seem to have accesses directly for it. That's annoying. Okay, well, we can start by at least getting the surface format, I guess. We'll call it format, we'll bind it. Surface format. What does it take? It takes the surface. Oh, we don't have that here. We're going to have to pass it into scope. Okay, and from the surface pixel format, we want to get the pixel format through the pointer. Let's get a builder going. Hack build fast with our file launcher. That's how you do. Oh, oh. Oh, that's not a helpful type error. Let's set that to stack. HCI, I think. And then restart the process there. Oh, that's something. Okay, point up pointer. What's the matter with this? It's sealed. Okay. Foreign pointer. Why don't you export your constructor? So we'll just get the, sorry, I might just get the format pointer. This would be surface pixel format, I believe. Oh, I did a whole bunch of oops. Let me fix that. surface. New surface. And we're going to surface pixel format. Format pointer. Surface format. Surface. Yeah, I'm going to pass that in here. Okay. Find but not use, that's fine. Okay. Format pointer is a pointer of STL raw types pixel format. Now, in order to get the BPP off of that, what do I gotta do? When I have a pointer type, what can I do with it? I can peek it. And then what do I get? X, surface. It doesn't say that it's in scope. Pixel format. Well, it should be in there. Alright, so if I got pixel format, then I could say PPP equal something. That's going to be pixel format. Bytes per pixel. I've got overloaded record dots, so I could just do that. Like this. Pixel format. Okay, so I'm getting the no instance has field for that. Probably because I haven't imported it. Lord STL types raw pixel format. Oh, that's the module name. Field.raw.types. There we go. Okay, define but not use BPP. Good stuff. All right, and then we got to, once we got the BPP, we can get our pixel. At least we can get pixel. Get the data from it. They still have to call STL get RBG. At least in this code. Let's look up at that. Oh, there's one in STL2. Okay, so do we have it in the wrapper then? Two. Okay, pretty low level, but we can do this. We can work with this. So we get the pointer to the pixel format. The word 32. Oh, that's the pixel data. And then we pass in the pointers to each of these elements. And then those pointers should contain the RGB data that we need to be storing inside our array. In order to render this back into a surface, when we want to set the pixel data, that'll be the next step. So let's not get too far ahead of ourselves. Let's just get this out. Okay. BPP, pixel pointer, that has the cast that we need to do as well. So this code, when we call this function getPixel, we're calculating the index into it outside the function. This is doing it at XY. And we have to give it an XY because it's got to convert, in order to figure out which pixel to get from the actual surface data, it can't use the width. It's got to like use the surface pitch here in order to calculate the offset for that pointer. So we need X and Y components, I guess. Let's bring this down here. Bring this over here. Here. X to be the image width. -1. And Y will be the image height. -Y. Do X, Y like that. Okay, then and then we set the offset for base off of here. So when we're using the storeable class to look into the data at this pointer, we have the ability to look at the alignment, the size of, we can peek the element offset, so we give the pointer and some integer value. Yeah, okay, so that's what that line's doing there in the C++ stuff, right? We're taking this pointer, the CUINT pointer, to be at this offset here. Right. And then, like in this case here, we're pulling out some data, blah, 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 from as an array. This is like C-like type stuff where I can kind of like devolve these pointers as arrays, but I think we can still work with that, maybe? We take the value. Well, this returns as a pointer, whereas storable is going to return us the value, that A there. Whereas we're in the C code there that we're looking at, it's giving us back a pointer A. Well, I think what we can do is just calculate the pointer, the base pointer offset value, and then use peek with those calculations for those cases where we want to pull out those other values. I think that would work. Pixel offset. Right, that's going to be our expression there. The surface pixels. That's a uint. Plus y. Times the pitch plus x. And then x times the bytes per pixel. So I think we could just do that. We could just do this part, the y times surface pitch plus that. Yeah. So we need the surface pitch there plus x times BPP. So let's get the pitch. How do we get the pitch? Does the surface record have a pitch for us? Pitch. Pitch. Surface pitch. Or is that in the pixel format? Structure, maybe. Pixel format. Ref count, clip direct user data, pixels, width and height, and the format. What is it in SDL? Pitch. Oh no, does the Haskell wrapper doesn't expose the pitch to us? That sucks. How could it not? Okay, that's super bad. That kind of stimmies us a little bit here. Okay. Ooh. We might be able to hack around this and get dirty. If the storable instance allows us to peek at an offset into the struct. As long as we can calculate the actual offset into this field here, we could get the pitch out. Oh my god. No. Oh, this is not good. This is bad. This is not good. Not good, not good, not good. I don't know if I want to do that, because then we'd have to calculate the size of that struct, as there's a struct member there. And the pixel format, that's easy enough, that's easy enough. It's just this guy here. Although it's just a pointer, so actually this might actually be a way we could do it. Yeah, we could hack our way in there. As long as we get the right value, and SDL2 probably not going to change the order of the struct fields, because I don't think it's under active development anymore, so might work. That's really frustrating that the Haskell raw type there has the format, the width, the height, the pixels, user data, clip rect, ref can't, like, I don't even know what I don't think that's probably an internal thing. No, it's in the reference count, yeah. Used by the locking. It doesn't have all of the, it just leaves out the pitch. Yeah. It's annoying. Arg. Okay, so I guess we're gonna, like, we don't really have much of a choice here unless we're gonna, like, fork the library or write a patch for them to add that field in on the record. Okay. Pitch. Get surface pitch. On surface. Yeah, so assuming we can write get surface pitch, then we should be able to put pitch here. And get the base pixel offset. What is get surface pitch? Takes a surface. Turns an IO. What is the type of pitch? It's probably int, cint. Leave it undefined for now. Okay, so then our get pixel function has to case match on BPP. Which we check on 1, I think 1, 2, 3, and 4. 1, 2, 3, and anything else 0. 1 is something, 2 is something, 3 is something. Otherwise, here's 0. Bad data, front data. Okay. In the case of 1, we just return peek. We just dereference p, so we just peek at it. At our pixel offset. Just at the base of which we calculated here. 2. What do we do? We just cast it to uint16, return that. No. What? Why? Just reading a uint16 off, but it returns as a uint32. Yeah. Some junk data on the end, I guess. Case 4 returns full 32 bytes. I don't think we need all of this. I think we just need this one. Which was case 4. Oh, sorry, 1, 2, 3, and 4. Let's forget all the others. Let's just do 4. Pixel peak element offset. Yeah, we don't need to do that. This is already 8 bytes. Yeah. So I think this will be fine here because peak element offset at pixel pointer from our pixel offset. We might need a from integral, depending on what type pixel offset ends up with. Yeah, cint. Because we are putting CU in back here as our return type, so I think that should grab off from the offset the 32. CU into the 32 byte size from Haskell. And because we don't need the pure there. Do, 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 do. PPP is a word 8. I'm expected to see int. That should compile. Okay, let's see now if the theory is correct. Ah, undefined, because we haven't defined get surface pitch. Right. Okay, let's do that now quickly. Pass. So we get the surface pointer, the raw pointer to the surface from from the surface structure. Okay, it doesn't have field accessors for it. So we're gonna just destructure it. Surface here. Bring it into scope. Okay. Then we can get the raw surface. From peeking at surface. Yeah, from the raw surface. This is where I need to know if we have a storable. We do. Okay, so now we have the raw surface. We can try and calculate the offset to get that peak value out. Oh, sorry, the pitch value out. Oh, yeah. We've got to skip 32. Another 8 bytes on the 64-bit platform there. 40, and then 2 ints. So I think we can take this. I think we have a size of for those objects. We might be able to just use that to calculate the offset for that. Maybe. Something there. What about the pitch offset? That's something. We'll put that in there. Right, it returns a C int. Okay. So, to get the offset, we're going to have to get the size of a CN32. the size of our C ints here? Value of the argument's not here, just the type. Alright, size of that plus the size of pointer. And then the size of the width and height. So 2 CU ints, or C ints. C ints. No, that's not though. That one. Oh, right, okay. Actually, wait. Expect the pointer C int. Did I get peaked element offset wrong? Pointer A. Oh, right, okay. Yeah. So this is because those A's need to match up. We're returning a C int here, so this will be which I'll return pure pitch. Maybe like a shorter way to write that, but like I think that's the general gist. It still thinks that's a surface type, probably. Yeah. Maybe we could just cast a pointer. Yeah, actually, with raw surface, I'm not even using it, but we don't need that. It says size of pointer's done, so that's probably true. Okay, and let's see. Yonder. This is a pointer to surface. It's not a pointer of arrays of surface. We're actually like trying to index into the structure itself. Oh, with padding and shit. Pardon the swearing. With padding, this isn't going to work terribly well. This is not gonna work so good. Because like the way, like obviously the way C packs structures is like with padding between each of the fields. So that it's aligned on word boundaries and or so it's byte aligned. Means like this UN32 might have some padding between it and the value here. That might be fine, but these ints could have padding between them. And then we hit the pitch. So actually, that means we should be able to index like 64, 64, 64. Assuming like that we're writing this for like a very particular platform. All the way down into get the pitch. 1, 2, 3, 4 values. And we could test that theory pretty quickly. Look at this. Okay, so then the only other thing here, though, is that the surface now, peak element offset is treating the pointer as if like we're indexing to like an array, like an offset of the same type things. So we probably need to cast this. Oh, but would peak element offset even understand if we tried to cast this? So what we're trying to do here? Maybe not. This probably isn't going to work, to be honest. I don't see how this would be a thing, but at this point now I'm starting to doubt that this is going to be a proper. I'll be able to. I don't think it's going to work. Okay. Let's just call it food. We cast the pointer. Right. Surface. To CU end. Or C end. And we try to peak element of foo. What I theorize is going to happen here when we do peak element offset through the historical class here is that it's going to, this offset value we give is going to count by the size of CNs from the base address, like the base pointer. Which is not what we want. Right, so we'd have to convert this calculation into CNs. Forgot to get that there. And this. Okay. Then we just need to get the full type FPL.raw types. Surface. And get rid of that. I might have to like import it properly, but let's see if that not imported, it's not in scope. Yeah. And I'll just import it qualified with raw. There we go. Let's see what weird data we get now. different. I think almost all zeros, actually. So just all this, all blank. So yeah, not working, not really a thing that we can do there. Ah, disappointment. Does SDL, the wrapper library, have a way of getting the actual pixel data? Good lord. Maybe I am just going about this the completely wrong way and I shouldn't be going so low level with it. Please tell me that we can do this. Pixel format name, the pixel format. Can't use it if can't get the data, the pixel data out. This is the section for pixel formats and conversion routines. Nope, renderer. GL stuff, all good. Do a quick Google search just to see if maybe somebody else has encountered this. My theory was that we could just get the raw 32 bytes values from the array and not even touch any of the pixel format stuff. Seems it's not the case. At least the way we're indexing into it isn't. I wonder. Well, because the theory here was that, like, the stride of these offsets matters. When we go to get the pixel, the offset isn't like 0, 1, 2, 3, or is it? Read a value from memory are regarded as an array of values of the same kind. The first argument specifies the start address of the array, and the second index into the array. The first element has index 0. We peek at the address. We do plus pointer on index times size of result. Right. So we have a size of... So that would be fine. Actually, that index in there would be fine. Size of result, size of result. So in our original implementation here, we're casting the pointer to a CU int. Maybe all that was maybe that was the only problem. It was just wrong cast. Okay, let's discard all of this, actually. New theory. Let's just go C int. If they're all C ints in the array, we don't need the component elements of it if we only care about that case 4 that we were looking at in that C++ example of like how to get the raw pixel data. So maybe that's fine. What's the problem here? Oh yeah, we didn't change the type here. C int and that pixel. Let me see texture from list. Pixels. Yeah, select. We're expecting CU int here. Texture from list. Let's go into source. Algorithm into wave function collapse. And we're going to pick out texture from list. A list of A's. Oh, because surface, yeah, surface is doing it. Good. And then we're going to turn that. And then set pixel. Change that over to CINTs. CINTs. Pixel pointer, and we're casting here again, so we'll fix that. Okay. Latest build, good. Well, compiles at least. Okay, we're getting quite a bit different data than we've seen before, at least. Yeah, we're still not getting quite the right results, though. So could still be junk data. Likely still junk data. What else could it be? It could be that the size of C int is not what I think it is. And in which case, foreign C.types. Maybe they have a sized. Oh, see, no, CU int was word 32. Okay. And C int is just int 32. What else could it be? Is our pixel image format maybe 64 bytes, not 32? Let's try. No harm, no foul. Let's get those clones. Alright, built. Let's see if that is the problem. Well, we're procedurally generating random data. A texture based off of random gobbledygook that's in my memory. Okay. Yeah, I think that's probably it's probably the pixel data. Probably the pixel data. How else could we test this? We could just immediately. Oh no, I think we did that before a bunch of streams ago. We just rendered the image we got right away without trying to access the pixel data to load into our texture type. Because that loads as a surface. And rendering a surface. Surface, draw surface. Surface bullet. And also create texture from surface. We're using a renderer. Here. I can do image tech. Create texture from surface. Image with renderer. And then leave that in there for now, but I'll just pass in tech. Alright, renders just fine. Okay, so yeah, that's essentially the problem. So yeah, I might have to give a patch to SDL2 in order to get that pitch, and maybe write the functions for it while I'm at it to get the raw pixel data, or maybe make a nice high-level interface for it, so that we don't have to drop down to such a low level in Haskell land in order to get at the raw pixel data on the surface image data there. That's what the issue is looking like at the moment. So yeah, it's rendering the whole texture. It looks a little wonky here from our base image because like it's doing some scaling and stuff because we set the window. It's rendering the whole thing. But anyways, yeah, because we should be seeing these values for these pixels in our input and output. We're not seeing these at all. And can't iterate over the raw pixel data directly the way we're doing the peak element offset. And we can't do it by pitch. Either. Until we get that raw feel. So I have a sneaky suspicion that the algorithm works, but we just can't visualize it yet. Dang it. Okay. Oh. How much time we got? We got 15 minutes. I don't know if that's going to be enough time to fork SDL2 here and make a PR for them. I wonder if they have any open for it. Bump linear up or down. Rectangle now. Pixel. Pitch. Ah, somebody's already requested it as a feature. Way back in 2018. Oh, they can actually get it. Oh, maybe we're saved. Ah, there we go. The surface width times the format BPP. Is what the pitch should be. But, yeah, depending on the pixel format. Okay, well, let's give this a shot. Let's see. Okay, get rid of all this. Okay, we're gonna have to do pass in the surface. Our pixel pointer here. X and our Y. As before. Zero to image height. X1. Image width. pixel, surface, surface. Okay. And then we want to get the raw pointer. And we want to get to pixel format. Oh, how did we do that? Oh, I think I totally forgot how it all worked. You gotta do it like 2 or 3 times before you can like put it in the old noggin. At least. Or if it's the array module, like 500 times. SDL2, yeah. Surface. Oh, it's on foreign storable. What am I doing? Okay, pointer to the surface. Right. Surface pointer, whatever that is. You peek at it to get the raw surface. And then the raw, we can get the BPP. From the raw surface. Pixel format. Well, surface format. Yeah. Peek at that, and then the BPP is the pixel format, bytes per pixel, surface format. Bytes per pixel. We have to import SQL dot raw dot types pixel format and SQL dot raw dot types raw. I think, maybe. I didn't like that. We'll do it this way. What was the field called? Surface format. Surface format. surface. There's an image surface up here, I think. Oh, I forgot to put the extra Y in there. Which we're not using yet. But where'd our feature request go here? So we take the surface width of the raw surface times the format BPP, then we get the pitch. Surface W of the raw surface times BPP. Okay, and then all right. Okay. Yes, so then we can calculate that offset. Yeah, and return that from this. Y times pitch plus X times BPP. From integral. We're going to put a format integral on it. Integral. More form integrals. It wants an actual int there. Oh, shadow, name shadowing surface format. Call raw format then. No. we're happy there. Okay, so we can get that pixel out, sort of. We still need to use the get RGB function, though, I think. Or the get RGB A. Right, so this is going to get out our CU int. All right, so that's going to get our pixel value. Oh, okay. Okay, so this just pulls out the components based on the pixel format from our pixel value. So since we don't really care about these, we should be able to just put them in the texture. So yeah, but the peak element offset function we said was doing that size of offset. I wonder if there's a way we can do it without size of. Peak byte offset, maybe. Return value for that would still be, it'd be pointer A, but, or, oh, pointer B, but it could return an IO of A, so it could return something that's different from the pointer, depending on what we demand it to be, I guess. So the caller, so if we did peak byte offset, we're telling A to be CU int. But we're giving it the byte offset, not necessarily the index offset with the size of and all that stuff. That's probably what we're looking for. That feels better. And looking at this, we're getting quite a bit different output this time. Not sure it's going to be the right output, but hopefully the pixel data is left intact and is good. Nope. But what are we getting? Okay, so this time our input texture is getting quite a bit different data. Maybe more in line with our actual raw image. And here we're actually getting all zeros in the output. Looks to be. Which I think should be black. But the way we're also putting the texture data back, the pixel data back into the texture and then rendering that is probably causing problems as well. Although we're using poke byte offset here, so that would be So the test for this, I think, would be to go back to main. think a quick test we could do for this, are we already in main? Blah, blah, blah. Is, take our input texture. And then we call toSurface to make it a surface again. And then we want to render it. We texture from surface. We'll just temporarily make it our input texture prime. And this should render exactly like the image that we had before. Our input image, basically, untouched. Algorithm running. Should probably turn the algorithm off to do this test here. What am I doing? It's all good. It's almost ready. There we go. Okay. So clearly we're not, our conversion, our set conversion is also needs some work here to convert back. Hopefully our loading function now is loading the pixel data properly, but rendering back into a surface, we're not doing something right here. I'm going to commit what we have here so far, though. We're kind of getting to the end of the stream, but I'm going to leave a link to the feature request / issue for this. That's looking a little more promising. So it's this, the toSurface stuff might not be quite right here. So let's just do a quick little review. Raw types. Oh, let's get rid of our little test code there. Okay, let's try it again. All right, so we just changed the pixels and how we get them. We get them by the XY values from the image's dimensions. And our getPixel function has been updated. So we get the actual pixel from the byte offset based on the pitch of the pixel format. CUint, I think, does translate to a word 32. It could still be that that's not the right type. No, it should be unsigned int. Yeah, get RGB is gonna... Yeah, unsigned int. So that's right. Yeah, that's word 32. That should be unsigned ints. So yeah. And then we get the byte offset from that. Okay. Learned quite a bit. A little bit. About, some some limitations of the SDL library that we need to address. So let's push that up, create a commit, stage it. Modify get pixel. We need pass in the surface so that we can calculate a byte offset to the pixel data based on the surface pixel format. We have to calculate pitch based on the image width and pixel format. Because the pitch field from the SDL surface struct, not exposed. Rapid library. And rapid. See. Key. Push, push. All right. So, learning a little bit about pixel formats, how to manipulate pointers, and how to do that in Haskell. I have another project, side project I'm working on the side to implement a wrapper library for the Tiger Beetle database. I think we've worked on it on the stream before, kind of like a little surprise stream. But I've made a little bit of progress on that, and I've been learning a little bit more about the Haskell FFI. It's pretty neat stuff, pretty good stuff. Really interesting FFI. Might be the next project we work on the stream once we get this visualizer working. But again, as I said at the beginning, if you have any ideas for projects you want to see happen on the stream, let me know. I'm kind of curious. Not really sure what to work on next, so taking ideas. Of course, you can find me online on the Metaverse, on Mastodon, here on the types.pl server. I'm Agent Ultra there, as well as here on Twitch, and elsewhere in the world, like on GitHub, where all this code is. So if you want to follow along with the code, if you dare, it's at Agent Ultra / wave function collapse. Okay. So next week we'll probably come back to this. Hopefully be able to get that load and to surface from surface function working so that everything's rendering fine and good and dandy, and get this visualizer wrapped up. What else? The link above my head. It goes to a cool website, declarative.tv. There's a link to a Discord server there where we have a channel for this stream. If you're watching on my YouTube channel where I back up all the VODs for this stream, and you want to like ask questions or like just hang out and talk about Haskell or your projects or whatever, join up there if you weren't able to chat in real time with the stream here, for all my friends in other time zones and such. Of course, you have all the links to my YouTube and stuff on here. I usually do these streams once a week on Tuesday evenings, about 10 after 8 in the Eastern time zone. So if you want to be notified when I go online, receive that notification, then just give us a follow here on Twitch, or like and subscribe on YouTube, and then you'll get notified if you have your notification settings set up that way when I go online. Because sometimes I do little surprise streams here and there for other things. And yeah, that's about it, I think. So may you have a great new year. Looking forward to hearing about all the things that you're working on and being able to work on cool new projects with you on this stream this year. So may all your monads be free and all your types check, and take it easy out there. Happy hacking.